Okay, let's unpack this. Today, we're doing something a little different, but I think incredibly valuable for anyone looking to really get up to speed on the nitty-gritty of artificial intelligence, specifically how organizations are navigating, the crucial and often pretty complex areas of AI governance, security, and risk management. We've taken a deep dive into a stack of industry-focused practice questions and their detailed explanations, the kind that really distill complex concepts into actionable insights. Think of it as maybe a shortcut to being well-informed in this rapidly evolving world of AI. Our mission today, to extract the most important nuggets of knowledge, helping you understand what's most important, why it matters, and how it applies in the real world.
Yeah, and what's fascinating here is how these aren't just theoretical challenges, right? The scenarios really highlight the practical obstacles and, frankly, the best practices that organizations are grappling with right now as they try and manage AI effectively. It's all about application and making sure sound principles are in place to, well, address the complexities AI brings.
All right, let's kick things off by laying down the foundation for AI governance and how organizations actually manage these powerful systems. So imagine you're at a financial institution and they've just rolled out an AI system to detect fraud. Super powerful stuff, right? But here's the catch. They haven't documented how this AI makes its decisions. So the first question we need to unpack is, why are AI governance policies primarily needed in a situation like this?
Well, the immediate and I'd say most critical reason, hands down, is regulatory compliance. I mean, think about it. Financial institutions are under intense scrutiny. Regulations often demand that any system, especially AI, which can impact customers like, say, denying a loan or flagging an account, must be explainable. If you can't show how that AI arrived at a decision, you're looking at potentially massive penalties, not to mention a huge blow to public trust and, well, brand reputation.
Right, so it's not just about getting the tech right. It's being able to prove you're operating responsibly.
Mhm.
And that goes beyond just avoiding fines, doesn't it? It touches on trust, ethics.
Absolutely. It really raises that fundamental question of how we balance the drive for innovation with our legal and ethical obligations. It's about building an AI system that's not just effective, but also accountable and fair.
That sets a clear precedent. Now, let's pivot slightly. Think about the very beginning of the AI journey. When you're training AI models, what would you say is the biggest challenge organizations tend to face?
Well, getting diverse and high-quality data sets is certainly crucial, absolutely. But I think the biggest challenge often revolves around ensuring data privacy and security during that training process, especially when you're dealing with sensitive information, right? Protecting that data from unauthorized access, leaks, or misuse becomes paramount. You're essentially building the brain of your AI, and if the data it learns from isn't secure, well, the entire system is vulnerable.
That makes perfect sense. Garbage in, insecure out, potentially. And speaking of sensitive data and potential issues, what if an AI hiring model starts to show bias? Let's say it's disproportionately rejecting candidates from a certain demographic. What's the best approach to ensure compliance in a scenario like that?
Okay, the best approach here is to conduct systematic bias detection and impact assessments. And critically, you have to do them continuously. This isn't a one and done kind of check. You need to thoroughly evaluate the model for disparate impact, meaning, does it disproportionately affect certain groups? And then you proactively remediate any issues you find. We're talking about adhering to strict guidelines like GDPR in Europe, the EU AI Act that's coming into force, even EEOC guidelines in the US. It's about fairness, yes, but it's also about avoiding significant legal repercussions.
So it's not just identifying bias once, but building in a constant feedback loop to catch it and correct it. That leads us to the critical components within AI solutions.
Yeah.
Beyond the algorithms themselves, what's a fundamental element that must be included in AI solution procedures?
Human oversight and validation. This is absolutely vital. AI is powerful, no doubt. But it's not infallible, especially when making decisions that have real-world consequences. Humans need to be in the loop to ensure ethical outcomes, catch unforeseen biases, and correct potential errors. It's really about combining AI's efficiency with human judgment and accountability.
I couldn't agree more. Human judgment remains irreplaceable, especially for those edge cases, right?
Mm.
Following on that, what would you pinpoint as a key regulatory requirement when we're talking about securing AI systems?
A key requirement is ensuring AI decision-making is explainable and auditable. Regulators really want to see the why behind the AI's what. And this transparency isn't just a security and accountability measure, it directly addresses the human impact of these systems. If an AI makes a critical decision, you need to be able to trace its logic, understand its data inputs, and audit its process to ensure it's fair and compliant.
That explainability, yeah, it's absolutely fundamental for building trust, both with regulators and the public. Now, let's take that explainability concept into a real-world scenario.
Yeah.
If a large multinational corporation uses AI for job screening, what's the primary purpose of ensuring this AI system's explainability? Is it just for general transparency or something more specific?
That's a great question. While it certainly provides transparency for HR managers so they can see why a candidate was ranked a certain way, its primary purpose in this context is actually to support legal and regulatory compliance. It's all about being able to demonstrate that the AI adheres to anti-discrimination laws, data protection laws, things like that. It moves beyond just knowing how it works to proving it works fairly and legally.
Ah, okay. So compliance is really the driving force there.
Yeah.
Given that, what's the best action an organization can take to truly improve the transparency and auditability of an AI system's outputs?
Well, you need to implement controls that are deeply aligned to the rationale behind the decision, the data that was used, and the potential impact of the AI's decisions. These controls provide clear, structured explanations for why the AI made a certain output. This makes its decisions traceable, easily auditable, and much simpler for humans to understand, which naturally builds trust and accountability in the system. It's about building in those guardrails, not as an afterthought, but as part of the core design.
That seems like a very systematic, proactive approach. Now let's zoom out a bit. Think about a global enterprise dealing with AI regulations across many different countries. That must be complex. What's the best approach to ensure legal and ethical alignment with all these different AI regulations across varied jurisdictions?
The most practical and effective approach, really, is to map the applicable regional and international regulations to your internal governance policies. And you do that based specifically on your geographical presence, trying to achieve a single global regulatory alignment that's often impractical, maybe even impossible. Instead, by mapping, you ensure compliance, you maintain ethical alignment, and you're audit ready for each specific jurisdiction where you operate. It's about localized precision, not trying for a global generalization.
Okay, that makes sense. Customize rather than seek a one-size-fits-all solution. And within that enterprise, what best ensures accountability and ethical oversight across all the various AI initiatives they might have going on?
Defining a formal governance framework for AI use. This framework is absolutely key because it clearly assigns roles for decision-making, policy management, and overall oversight. It promotes responsible and ethical AI use consistently throughout the entire enterprise, giving you a structured way to manage all your AI projects.
A clear structure is definitely helpful for managing complexity. Following that, if a highly regulated organization is expanding its AI use, what best ensures these new AI initiatives align with both their business goals and their ethical standards?
Implementing an AI steering committee. This committee, usually comprised of various stakeholders from different departments, legal, IT, business lines, ethics, maybe becomes directly accountable. They ensure that AI projects not only advance business goals, but also meet all regulatory requirements and address ethical concerns. It provides that high-level cross-functional oversight and direction that's just essential for strategic alignment.
Got it. A steering committee for that high-level view. And finally, for this foundational section, what's the most critical component in an AI framework when we're talking specifically about ensuring system security?
Without a doubt, it's secure data handling and model integrity verification. Think of it this way. If the data your AI trains on is compromised, or if the model itself is tampered with, then all your efforts in governance or explainability can be undermined completely. This component ensures the model and its associated data sets haven't been maliciously altered. It prevents biased, harmful, or simply incorrect outputs. If the underlying data or model integrity is compromised, everything else is at risk.
Right, that lays a really solid groundwork. Now let's shift our focus a bit to the strategies, policies, and procedures surrounding AI. We've seen a huge explosion in the use of generative AI tools lately, haven't we? So if an enterprise has expanded its use of these tools, what's the most important reason they should review and update their existing AI policy?
Ugh. The most important reason is simply that the regulatory and technological environments around AI are evolving at lightning speed, seriously fast. An AI policy isn't a static document you just set and forget. It must be periodically reviewed and updated to remain relevant. You've got rapidly changing laws, emerging risk factors, even potential misaligned usage practices by employees popping up. What was ethical or compliant yesterday might not be tomorrow.
Constant adaptation is absolutely key in this space then. Now, let's say an enterprise is planning to implement an AI chatbot. From a control perspective, which service model, IS, PAS, or SAS, gives them the most control over their data and the AI model itself.
For maximum control, you're definitely looking at infrastructure as a service, or IS. With IS, you manage the operating systems, the applications, and your data. It gives you the most control over the underlying infrastructure. This allows you to specifically control data for training, directly manipulate the model, and implement your own security controls. It's really the hands-on approach if deep customization and control are your top priorities.
Good to know for those who need that granular control. Moving beyond service models, what's the most important factor when an organization is deciding whether to build their own AI recommendation engine in-house or maybe procure one from an external vendor?
Strategic alignment with business needs. This is critical. It isn't just about cost or speed, though those are factors. It's about determining the long-term viability and appropriateness of the solution. You need to ensure whatever engine you choose or build truly supports your long-term growth and core objectives. Does it fit your unique business model? Will it evolve with your strategy? That's the crucial question.
Strategic fit always have to come first. Makes sense. And speaking of employees using these tools, what's the first action an organization should take to ensure the responsible use of a generative AI assistant among its workforce?
You absolutely need to provide targeted training to employees. And crucially, you have to couple that training with a clear acceptable use policy, or AUP. Training ensures employees understand the scope of authorized use, the sensitivity of the data they might be interacting with, and the behavioral expectations when using these tools.
Yeah.
This dual approach training plus policy significantly reduces misuse and ensures alignment with your ethical AI principles. You need to equip your people with the knowledge and the guardrails first.
Education and clear guidelines are absolutely foundational. Now, we've talked about bias a bit already, but which type of bias is present not just in specific AI datasets, but can be woven across organizational practices and processes throughout the entire AI lifecycle?
That would be systemic bias. This type of bias isn't confined to just a single data set or a particular phase like training. It can be deeply embedded across the entire AI lifecycle. It encompasses everything from how data is collected in the first place to the organizational norms and processes involved in model development and deployment. It's a really pervasive issue that requires a holistic approach to address effectively.
That sounds like a deep-seated problem, requiring a broad solution. So, following on that, what best helps to reduce algorithmic bias and discrimination, especially the kind that might be systemic?
Ensuring your test plans explicitly include edge cases specifically designed to address potential bias. While regular audits are certainly recommended, directly testing those corner cases, the unusual or less frequent scenarios, is what truly targets bias effectively. It's different from just general data cleansing or basic unit testing. You have to specifically look for those tricky situations where bias might appear or get amplified.
Targeting those tricky scenarios, not just the obvious ones. Okay, now let's say an AI AUP, that acceptable use policy we just discussed, is implemented, but violations are still occurring. People aren't following it. What's the most effective control an organization can put in place to enforce compliance and actually reduce future violations?
You need to define clear investigation procedures and, importantly, follow through with disciplinary consequences. An AUP without teeth isn't really an AUP, is it? Clearly defined enforcement processes are essential to promote accountability and deter misuse. It supports the credibility of your AI policies by showing that you're serious about them. Without consequences, the policy just becomes a suggestion.
Accountability is absolutely key there. So, moving to a practical implementation, what's the first action an organization should take when they're implementing a new AI solution, let's say to detect financial fraud?
The very first action, before anything else, is to identify the specific business challenges, the stakeholder needs, and the solution requirements. Before you even think about algorithms or data sources, you have to know precisely what problem you're trying to solve. This foundational step ensures the AI solution aligns with your core business objectives and that it will meet all legal, regulatory, and ethical requirements throughout its entire life cycle. Otherwise, you risk building something brilliant that, well, solves the wrong problem or creates new ones.
Define the problem before you build the solution. Seems obvious, but I bet it's often overlooked. Now, when operationalizing an AI governance framework, what's the best reason to meticulously document all those AI-specific procedures?
The best reason is to ensure consistency in AI data processing. This consistency directly helps to reduce the risk of unintended model behavior, which can be unpredictable. Documented procedures provide a clear blueprint, minimizing errors and promoting trust by outlining exactly how AI systems should be developed, deployed, and monitored. It ensures everyone is on the same page every single time.
Consistency prevents surprises and builds reliability.
Got it. When developing the very first acceptable use policy specifically for generative AI tools, what's the most important component to include in that policy?
You absolutely need to define how that policy supports your strategic enterprise objectives. Strategic alignment is the absolute foundation of an effective AUP. It ensures the policy isn't just some compliance document gathering dust, but that it actively supports organizational goals, fosters responsible adoption, establishes accountability, and contributes to long-term success. It's about connecting the policy directly to the bigger business picture, bringing it back to the overarching strategy. Good point. Now, let's talk about AI data lifecycle management. What's a key factor in effectively managing that data throughout its entire journey?
Defining clear data retention schedules based on data sensitivity. This is vital. Retention policies ensure that data is stored only for as long as it's necessary and legally permissible. They align with both legal obligations and business needs. And data sensitivity is a critical factor here, dictating how long different types of data can or should be kept to minimize risk. You don't want to hold on to sensitive data longer than you have to.
So data sensitivity driving those retention periods. And along those lines, what's a key consideration when you're establishing procedures for data privacy in AI solutions?
Ensuring informed consent and maintaining data confidentiality. These are fundamental pillars, really. It's about upholding individuals' privacy rights and meeting the stringent regulatory standards that govern data privacy globally. Without informed consent and robust confidentiality measures, you risk serious legal headaches and a severe erosion of trust.
Critical for both trust and legality, absolutely. And finally for this section, if an organization is launching a responsible AI or RAI program, what's the most effective first action they should take to get it off the ground successfully?
Establish strong leadership support from the very top. A responsible AI program, to truly succeed and have impact, requires active, visible backing from leadership. Leadership needs to model ethical values, build trust throughout the organization, and drive enterprise-wide adoption. Their commitment sets the expectations and direction for long-term accountability, making it clear this isn't just some departmental initiative, but a core organizational value. Without that leadership buy-in, it's likely just a wish.
Building right on that, let's dive into AI assets and data lifecycle management. This is so crucial for maintaining security and compliance day to day. So, what's most important in the AI data lifecycle to ensure compliance with all those data regulations out there?
Defining clear data retention and disposal policies. It's not enough to just collect and use data, right? You need explicit policies that ensure data is stored only as necessary, and then securely disposed of when its purpose is fulfilled. This directly aligns with legal and regulatory requirements, minimizing the risk of over-retention, which can be a huge liability. It's about managing the full life cycle, cradle to grave, for data.
Right. Knowing when to securely let go of data is just as important as how you acquire it. Speaking of securing data, if a government agency is moving AI training data, especially personal data, to long-term storage, what best ensures its security while it's just sitting there, at rest?
Data encryption, period. Encryption protects sensitive information from unauthorized access, from breaches or misuse. It's an absolute priority for data at rest, especially highly sensitive personal data like that. If someone somehow gains access to the storage, the encrypted data remains unreadable. It's a fundamental control.
Encryption, always a good idea, especially for government data. You bet. Let's consider a scenario. A lone dataset is being shared with a third-party vendor to improve an AI risk model. What's the primary reason for anonymizing that dataset before sharing it?
The primary reason is ensuring compliance with regulations. Anonymizing data removes the ability to link it back to specific individuals. This is critical for protecting personally identifiable information, or PII, and it ensures you comply with data privacy regulations like GDPR or other regional equivalents. It's about safeguarding privacy while still being able to leverage the data for valuable insights.
Compliance-driven and privacy-focused. Got it. Now, for a financial institution looking to categorize its AI models for effective risk management, what's the best approach for that categorization? How should they group them?
The best approach is definitely to categorize them based on their potential business impact and their inherent risk level. This isn't a one-size-fits-all situation at all. By classifying models this way, organizations can then implement security controls and risk mitigation strategies that are specifically tailored to the unique threats and vulnerabilities of each model. A low-impact internal tool needs very different controls than a high-impact customer-facing financial model.
Tailored security based on impact and risk. That makes a lot of sense.
Yeah.
Now, this is a tricky one. What security vulnerability can actually persist even after an AI system has been fully decommissioned from production environments. It's gone, right?
Residual data. This often gets overlooked, seriously. Even after an AI system is shut down, sensitive data can linger. In backups, log files, temporary files, maybe even mismanaged cloud resources. If this isn't properly sanitized or destroyed, this leftover data can lead to data breaches, compliance violations, or even intellectual property theft long after the system is supposedly gone. It's like a data ghost in the machine that can still cause real problems.
The ghost in the machine, indeed. Scary stuff. So when we're talking about managing security risks associated with open source components, which are everywhere in AI systems, what's the first step an organization should take?
The very first step has to be creating and maintaining an accurate software bill of materials, or SBOM, for each AI system. Think of an SBOM as like a comprehensive ingredient list for your software. It details every single open source or third-party component within it. A precise SBOM is foundational for identifying vulnerabilities, managing licenses, and assessing supply chain risk in those components. You need to know exactly what's actually in your system before you can even begin to secure it properly.
SBEAM is the indispensable starting point. Makes sense. When implementing data classification in an AI environment, what's the primary consideration? What drives that process?
The classification levels themselves. Understanding these levels, whether data is public, internal, confidential, or highly restricted, forms the absolute foundation for how that data should be handled, protected, and processed within the AI environment. It dictates your entire data handling strategy, everything from access controls to encryption requirements.
The foundation of secure data management. Those levels. What's most important when managing data that has been gathered from another source for use in an AI model? Bringing in external data.
Data provenance and regulatory compliance. Verifying data provenance, essentially where did this data come from and how is it collected, and ensuring it adheres to all relevant regulations is paramount. This is the most important consideration to verify the data's origin, its integrity, and its legality, especially when you're bringing in external data sets into your AI models. You have to trust the source.
Knowing where your data came from and if it's legally acquired is absolutely vital. Now, circling back to decommissioning again, which oversight would result in the most significant security vulnerability during AI system decommissioning? What's the biggest mistake?
Retaining active service accounts and application programming interface, or API, keys for the model artifacts. This is a massive oversight, a huge one. It creates persistent security gaps that malicious actors can exploit long after a system is supposedly retired. It effectively leaves a back door wide open into your environment. It's like you've taken the house down, but you've left the keys under the front mat.
That's a huge oversight, a critical one. Wow. How would you best describe the role of data quality in AI model performance? We hear about it a lot.
Well, high-quality data ensures better accuracy and significantly reduces the need for constant model retraining. It really is the old adage, garbage in, garbage out. Poor quality, irrelevant, or biased data will inevitably lead to incorrect predictions and unreliable results. Conversely, high-quality, relevant data dramatically improves accuracy, boosts reliability, and cuts down on ongoing maintenance efforts. It's foundational.
Quality in, quality out definitely applies to AI. During the data collection phase of the AI lifecycle, right at the beginning, what's a primary concern organizations should keep top of mind?
Privacy and consent violations. This is a critical ethical and legal concern right from the get-go. Collecting data without proper, explicit consent from individuals or ignoring established privacy regulations like GDPR can lead to severe legal and ethical issues down the road. It impacts trust and jeopardizes compliance, often before the AI model even begins training. You have to get this right first.
Critical from the very start of the process. To ensure visibility into AI training data provenance for effective AI asset and data lifecycle management, what's the best approach? How do you track it all?
Implement a centralized data catalog with automated lineage tracking capabilities. This isn't just about having a static list, it's about real-time tracking. This approach offers genuine, real-time data provenance, dramatically enhancing governance and security by providing a clear audit trail of data origins, all its transformations, and its usage across all your AI systems. It provides that crystal clear audit trail automatically.
Automated tracking for maximum visibility. I like that. When classifying data to be used for AI applications, what should be done first? What's step one?
Define application-specific thresholds. While it's important to know what data you have through inventory, absolutely. The absolute first step in classification is defining how that data will be used in the specific application. These application-specific thresholds directly tie to its purpose, its criticality, and the risks involved, guiding the entire classification process based on context.
Thresholds as the initial guide for use.
Yeah.
Okay. What is a significant issue with AI-generated content, like text from LLMs, that can impact data integrity?
The fundamental issue is that AI tools cannot inherently guarantee the integrity of the data they generate. They just can't. AI-generated content isn't always accurate or current or factual. It can hallucinate. This makes it very difficult for users to determine what they can truly trust or verify. This means human oversight is still absolutely necessary to validate that information, especially in critical applications. Don't blindly trust AI output, ever.
So human validation remains paramount. Definitely. Once an AI asset is deployed and running, what's the best practice for managing it throughout its operational life?
Implementing version control and robust access logs. Version control gives you a clear history of changes and iterations for the AI model itself, while access logs provide insight into who has interacted with it, when, and how. Together, these provide crucial insight into AI model operations, supporting traceability, security, and overall governance of your deployed AI assets.
Version control and logs for comprehensive accountability. When an organization is expanding its use of AI, maybe across many departments, what's the best way to establish visibility and oversight of all its AI-related assets? How do you keep track?
Integrate all AI-related components into your existing inventory system, if you have one. Centralizing AI tools, models, and data into a single, established inventory system ensures comprehensive traceability, oversight, and management of both deployed and non-deployed assets across the entire organization. A centralized view is always better for managing complex assets like AI.
A unified, centralized view is definitely ideal. And finally, for this section, what's the most effective method for classifying the AI training data itself?
Using sensitivity labels based on data criticality. This is about more than just broad categories like confidential or public. Sensitivity labels ensure that data is handled according to its specific level of criticality and the potential impact it could have if compromised. This directly supports the implementation of appropriate, tailored security and compliance controls throughout the data's lifecycle within the AI system.
All right, let's pivot now and dig into AI security program development and management. This is about building that security foundation. When embarking on the journey of implementing an AI solution, what would you say is the most critical first step for its overall success?
The most critical first step, unequivocally, is having a well-defined problem. It sounds almost too simple, right? But without a crystal clear understanding of the specific business problem the AI solution is meant to solve, the entire project risks failure. Seriously. It might not align with business objectives, or it might solve a problem that doesn't actually matter that much. It's the absolute foundational step to find your problem before you even think about building the solution.
Define the problem before you build the solution. Excellent advice. It keeps coming up. Now, to truly align an organization's AI security strategy with constantly evolving regulatory requirements, what approach best assists them in staying compliant?
Conducting regular audits and compliance assessments. This isn't a one-time check-off list. It needs to be a continuous process, really. Routine audits and compliance reviews ensure that your AI systems and their controls consistently meet regulatory obligations. This helps identify any gaps early, maintains accountability, and ensures you can adapt promptly to changing legal requirements.
So, consistent audits keep you on track and compliant. Makes sense. And speaking of accountability, what's the best way to ensure accountability in AI decision-making processes? How do you achieve that?
Implementing transparent documentation and robust audit trails of every single model decision. Transparency is paramount for accountability in AI. It really is. It provides clear, traceable records of how and why a particular decision was made. This is crucial for both internal oversight and, importantly, demonstrating compliance to external auditors or regulators.
Transparency truly builds accountability. I see. Now, for a scenario, consider an AI system assisting with medical diagnoses, pretty critical stuff. What would be the key requirement for that system to be considered truly trustworthy?
Human oversight, absolutely, especially in critical use cases like healthcare, where decisions have profound human impact. Human agency and oversight are absolutely essential. They ensure trustworthiness, ethical soundness, and accurate results. The AI assists, it provides insight, but a qualified human must retain final judgment and responsibility. It's about humans in the loop, especially when lives are on the line.
Humans in the loop, especially in critical sectors like healthcare, absolutely. When we think about the AI software development lifecycle, the SDLC, what best ensures that security is deeply embedded throughout the entire process, not just, bolted on at the end?
You have to incorporate security requirements right during the planning and design phases. This is the shift-left approach in security, which is becoming standard practice. By integrating security considerations early, you enable proactive risk identification and mitigation. You prevent vulnerabilities from being designed into the system from the outset, which is far more efficient and effective than trying to find and fix them later.
Shift left on security, definitely a best practice. Now, if an organization needs an AI system to detect and prevent complex cyber attacks, the kind that involve intricate nonlinear relationships, which AI model should they typically implement for that? What's a good choice?
A random forest model is often a very good choice here. This model is highly effective for such scenarios. It works by creating multiple decision trees and then combining their predictions for greater robustness and stability. This ensemble approach effectively mitigates overfitting risks and handles those complex nonlinear relationships characteristic of sophisticated cyber attack patterns, making it very suitable for detection.
Random forest for handling those complex threats effectively.
Yeah.
Now, if you're looking to track and improve the security posture of a large language model, an LLM that's integrated into customer-facing applications, what should the organization establish first? Where do they start?
They should define key performance indicators, or KPIs, and key risk indicators, or KRIs, that are specific to the LLM's security risk. These metrics are absolutely foundational. You can't manage what you don't measure. They provide a structured way for continuous monitoring of the LLM's performance and system behavior related specifically to security.
Metrics to measure the progress in health.
Right.
What feedback loop primarily ensures that AI outcomes align with organizational goals, especially in a dynamic, changing environment?
Business feedback. This is distinct from, say, technical or data feedback loops. Business feedback directly optimizes AI models to drive specific business value, ensure compliance, and improve operational efficiency. It's about taking input directly from key stakeholders about the desired outcomes and how the AI is actually performing against those real-world business goals.
Business alignment is paramount, always. When establishing security metrics for AI deployments, what approach best reveals the true security posture of an organization's AI deployments? What's a really telling metric?
Measuring the mean time to detect and respond to adversarial attacks against AI models. This metric is incredibly insightful because it provides a comprehensive view of your operational readiness against significant AI-specific security threats. It shows not just if you can identify an attack, but how quickly you can effectively react and mitigate it. It measures your agility.
Time to detect and respond. That's a crucial, actionable metric. I like that. And to track and evaluate the effectiveness of an organization's AI security posture over time, what provides the best method?
Key performance indicators, KPIs, specifically tailored to AI security objectives. KPIs offer measurable, continuous indicators of your AI security control effectiveness. Things like maybe anomaly detection rates, remediation times, or reduction in attack surface. They enable you to conduct trend analysis and monitor performance consistently over time, ensuring your security posture is actually improving and not just static.
KPIs for the long game, showing trends. Gotcha. And finally, for this section, what's most critical for conducting regular risk assessments and updating continuity strategies for AI systems to effectively address misuse and security breaches?
Frequent evaluation of AI security gaps and the subsequent updating of response plans. The threat landscape for AI is constantly shifting. It's incredibly dynamic. This ongoing evaluation is essential for identifying potential vulnerabilities before they become critical and ensuring your continuity strategies remain effective against current threats. It helps organizations stay ahead of emerging threats and adapt their mitigation efforts proactively. It's about continuous vigilance.
All right, that brings us to a really vital area. Business continuity and incident response, specifically for AI systems. Things will go wrong eventually. So, when facing a major disruption, what's the most appropriate action to ensure an AI system's resilience? How do you make sure it can bounce back?
You absolutely must integrate the AI models, their associated data, and the underlying infrastructure directly into your broader business continuity, or BCP, and disaster recovery, DRP, planning. This holistic approach ensures that critical AI-driven services can resume promptly and effectively during any disruption. It considers all their unique dependencies and components. It's about seamless integration for true resilience.
Seamless integration for maximum resilience. Okay. Now, if a financial institution is integrating AI into its incident response strategy, what would be the most effective use of AI in this context? How should they leverage it?
AI should primarily support human analysts. It should provide data-driven insights while humans maintain critical oversight. Full automation in incident response, especially complex ones, can lead to misclassification or biased responses, which could have really serious consequences. AI's role here is to act as a co-pilot, assisting human judgment and accelerating analysis, not to entirely replace it.
AI as a co-pilot, not the sole pilot. That makes a lot of sense, especially in high-stakes situations like finance. So what's the best metric to demonstrate an AI solution's effectiveness in assisting security analysts through incident response? How do you measure that value?
Mean time to detect and respond. MTTD and MTTR. This is arguably the most meaningful metric for demonstrating productivity and efficiency gains. It directly tracks how much time analysts have saved in identifying and resolving incidents, thanks to the AI's assistance. It quantifies the real-world impact clearly.
Quantifying that efficiency is crucial for justifying the investment. What's most critical for developing and implementing robust business continuity plans, BCPs, for AI systems specifically to address security breaches and exploits?
Developing strong AI guardrails and actively monitoring for jailbreak attempts. Now, just to clarify, a jailbreak attempt is when a user cleverly manipulates the AI's input, its prompt, to bypass its safety measures. They're trying to force it to generate content it wasn't designed to, like harmful advice, biased opinions, or even malicious code. These guardrails and the monitoring for such attempts are crucial to prevent this kind of misuse and ensure ethical compliance within AI systems. They manage potentially harmful content generation and detect those unauthorized attempts to bypass controls.
Guardrails against misuse, that's definitely key. So let's say an AI-based intrusion detection system, an IDS, failed to prevent a zero-day cyber attack. It missed it. What action best helps its business continuity posture for similar future incidents? How does it learn?
You should use AI tools to perform forensic analysis of the incident, figure out what happened, and then crucially retrain the detection models using that updated post-attack data. AI can significantly accelerate forensic investigations, identify new attack patterns that weren't known before, and rapidly adapt to emerging threats. This improves future detection accuracy and enables adaptive retraining, making the system smarter and more resilient for the next time.
Learn and adapt with AI, making the system smarter over time. What's the first action a team should take to ensure effective incident handling when an AI system is compromised? What's step one when the alarm goes off?
Activate the incident management team and immediately limit the activities of the AI system. Containment. Containment is the critical first phase in any incident response. You have to stop the spread and minimize the damage. This means immediately limiting the AI's activities, maybe taking it offline, and isolating any compromised systems to prevent further harm or data loss.
Containment first, always. Stop the bleeding. And to put a finer point on that, if an AI-powered credit scoring model is compromised by ransomware, ouch, what's the first action the incident response team should take?
Isolate the infected AI system and disconnect it from network storage immediately. Again, containment is the absolute immediate priority. You need to cordon off the compromised system to minimize the impact of the ransomware incident on other systems and prevent it from spreading further across your network or encrypting more data.
Isolate and contain to minimize impact. Got it. What's most critical for developing and implementing BCPs for AI systems to prevent misuse and ensure ethical compliance, especially thinking about generative AI again?
Developing those AI guardrails and monitoring for jailbreak attempts, we're mentioning these again because they are just that vital, especially with the power of modern Gen AI. These specific measures directly prevent misuse and ensure ethical compliance by managing harmful content generation and detecting when users try to force the AI to produce unintended or malicious outputs. They are your primary defense against that kind of exploitation in operation.
Guardrails against misuse, yes, it's clearly a high priority item. Now, if an AI solution has significantly increased productivity, it's a real asset, but it hasn't been integrated into the organization's existing continuity plans yet. What process would identify the criticality of this asset to business operations?
A business impact analysis, or BIA. A BIA systematically identifies the criticality of various assets, including AI systems, and evaluates their potential impact on business operations if they were disrupted. This analysis is absolutely essential for developing robust business continuity plans that are tailored to the organization's specific needs and priorities. It ensures you protect your most vital assets, including those newer AI ones.
BIA for critical asset identification, including AI. Makes sense. What is a key requirement for an AI incident response plan and IRP? What makes it different?
Defining specific protocols for AI failure detection, escalation, and recovery. An AI IRP must supplement your existing enterprise IRPs. It needs to provide very specific, detailed steps for handling failures unique to AI systems. This includes how to accurately detect issues like model drift or poisoning, how to escalate them through the proper channels, and how to effectively recover the AI system, maybe retraining, maybe rollback to restore normal, trustworthy operations.
Specific protocols for those unique AI failures.
Right.
If an AI-driven security system failed to prevent a cyber attack, what's the most effective step to take afterward to improve future response efforts?
Analyze the incident data thoroughly and use those insights to refine the AI detection algorithms, improving response accuracy. This is all about continuous learning and improvement from failures. By thoroughly analyzing the data from the past incident, you can continuously improve the AI's ability to detect similar or even evolving future threats more accurately and efficiently. It makes the system smarter and more resilient over time.
Continuous improvement and adaptation from real events. Now, after a cyber attack, which factor presents the greatest challenge in ensuring AI system continuity? What's the hardest part of recovery?
The integrity and security of the training data. This is often overlooked during recovery. If your training data itself was compromised or corrupted during the attack, even if you restore the AI system's code and infrastructure, it may continue to make faulty, biased, or incorrect decisions because its foundation is flawed. This poses a significant, persistent challenge to the continuity and trustworthiness of the AI system, even post-recovery. It's the integrity of the knowledge base.
The integrity of the foundation. Absolutely.
Yeah.
That's a tough one. And finally, for this section, what's the primary challenge of using AI for real-time incident detection? What's the downside?
AI models, especially complex ones, may generate a high number of false positives. This leads to unnecessary alerts and potentially wasted response actions. While AI is incredibly good at processing vast amounts of event logs and identifying patterns, the inherent challenge of distinguishing genuine threats from benign anomalies can lead to frequent false alarms. This can cause alert fatigue for human analysts, making them less responsive and ultimately making the system less effective in practice for real-time detection. Tuning is key.
Okay, that was a really comprehensive look at incident response for AI. Now let's dive into AI risk assessment, thresholds, and treatment. It's all about understanding, quantifying, and then actively mitigating the unique risks AI presents. So what most effectively supports data integrity risk management for AI systems?
Yeah.
How do you keep that data clean?
Continuous monitoring combined with dynamic feedback loops, manual checks, and just initial data validation. They're simply insufficient for the dynamic nature of AI systems and data streams. You need ongoing, ideally real-time monitoring to identify and promptly address any data integrity issues as they emerge. This ensures the data feeding your AI remains reliable and trustworthy over time, which is absolutely critical for the AI's performance and safety.
So continuous monitoring is truly essential for data integrity. Can't just check it once. When it comes to ensuring conformity with regulations, what's the best AI risk treatment option? How do you manage risk to stay compliant?
Setting adjustable AI risk limits or thresholds to stay compliant. Regulations and the risk landscape itself are constantly evolving, right? By having adjustable risk limits, you ensure that your risk treatment strategies remain effective and proportionate over time. It allows you to dynamically adapt to new requirements and emerging risks. It's about flexibility within a compliant framework.
Adaptability for consistent compliance. Okay. Now, when integrating AI security risk into existing business continuity and disaster recovery planning, what should an organization do first? Where do they start that integration?
You absolutely need to identify your critical AI systems and all their dependencies first. This is foundational work. It informs all subsequent planning by allowing you to focus your resources on your most vital AI systems and their supporting components. And crucially, it helps you identify any gaps that need to be addressed in your existing continuity plan to properly cover these AI assets. You can't protect what you don't fully understand is critical.
Identify the critical assets, then plan around them. Makes perfect sense. When prioritizing risk management for third-party AI models, which are becoming more common, what practice best ensures effective context-specific risk treatment across the full system lifecycle?
You need to require third-party AI models to comply with your internal risk control frameworks. And this needs to be backed by dynamic performance monitoring and periodic reassessment throughout the contract. This ensures integrated and consistent risk management across your entire portfolio, even for external components. It helps you effectively manage the complexity and potential vulnerabilities introduced by those third-party elements. Don't just trust, verify continuously.
Consistent frameworks and ongoing checks, even for third parties.
Right.
Which provides the most effective mechanism for ensuring that the data used in retraining an AI model is trustworthy and aligns with enterprise AI risk policies. Retraining data can be tricky.
Implementing structured, risk-informed review processes that include a human-in-the-loop, or HITL. And that human review should be based on very structured criteria, not just gut feeling. This combination is powerful. It mitigates data quality issues, addresses potential bias drift, and ensures compliance by validating AI outputs with human judgment at critical points in the retraining process.
Human in the loop. Again, a recurring and critical theme, especially for retraining. When training an AI model initially, what's the most effective method for managing the risk of data poisoning? How do you stop bad data getting in?
Implement rigorous input validation and data sanitization processes before training. This directly mitigates the risk by ensuring that only trustworthy, clean data is used for AI model training. It's your first and most critical line of defense, blocking malicious or corrupted data at the source before it can ever infect your model.
Validate inputs, sanitize data, prevent the poison from entering in the first place. Which action most effectively ensures that an organization can truly adapt to evolving AI risk throughout the entire AI system lifecycle? How do they stay agile?
Implement continuous monitoring combined with periodic risk reassessment and clearly defined thresholds for action. This multi-layered approach allows the organization to dynamically respond to emerging and changing AI risks. It provides clear triggers for management responses when those predefined thresholds are crossed. It's about staying agile in a dynamic risk environment.
Dynamic response to dynamic risks. Makes sense. When integrating AI risk management into existing organizational practices, which best ensures effective risk prioritization across the entire enterprise, how do you make sure AI risk gets the right attention?
Establishing systematic policies that directly link AI risk measurement to your overall organizational risk tolerance. This ensures that AI risks are prioritized consistently alongside all other enterprise risks: financial, operational, reputational. It allows for logical allocation of resources and attention across the entire company. It aligns AI risk with your broader business risk strategy.
Aligning AI risk with overall organizational risk appetite. Good. What best supports integrating AI risk management into the broader enterprise risk governance program? How do you weave it in?
Establish a cross-functional AI-specific risk oversight team or committee. This team provides dedicated expertise and ensures that AI-specific risks are managed continuously, that they are aligned with the organizational strategy, and that they are fully integrated into the existing enterprise risk governance framework. It's about specialized oversight within a unified structure.
A dedicated team for AI risk management makes sense, given the unique challenges. What's the best method to manage the risk of unfair customer treatment that might be caused by data bias in an AI system? How do you fix that bias?
Retrain the model with balanced data and combine that with fairness indicator tracking. Retraining with balanced data directly addresses the source of the bias in the training set, and by actively tracking specific fairness indicators during operation, you maintain continuous oversight, which is core to responsible AI risk treatment. It's about proactive correction and ongoing validation for fairness.
Proactive bias mitigation is critical for fairness. Now, if an AI system initially showed gender bias, and after mitigation efforts, some residual bias still remains, it's not perfect. What's the best course of action to ensure an acceptable level of risk before deploying it?
You have to document the impacts of that residual bias and transparently inform all relevant stakeholders of the remaining risk. Transparency is absolutely paramount here. It's an ethical imperative. It ensures that ethical and legal responsibilities are addressed, allowing for informed decisions by those who need to understand the remaining irreducible risk before the system goes live. They need to accept that residual risk.
Transparency about residual risk, so everyone is aware and can sign off. What's most critical during the early stages of an AI impact assessment to ensure the system's risk is evaluated appropriately across its intended deployment context?
Identify the intended uses for which the system is designed and tested. Clearly define them. The definition of the intended use is foundational to your entire risk analysis. It really is. It frames who the key stakeholders are, what potential harms could arise from that specific use, and what regulatory triggers might apply for that particular application. You can't assess risk effectively if you don't know exactly what the AI is supposed to be doing.
Intended use first, a guiding principle for risk assessment. Which feature engineering technique is most critical for conducting regular risk assessments and updating continuity strategies in AI models?
Feature selection. This is crucial for identifying the most relevant features in your data that actually drive predictions. It directly improves model performance, helps prevent overfitting, and supports the creation of robust and reliable models. All of these factors are essential for effective risk assessment and for developing solid continuity plans for your AI systems. Better models are less risky.
Feature selection for building robust and reliable models. Okay, what practice most effectively minimizes model selection risk for an AI model, especially when it's going into a critical application? How do you pick the right model?
Conduct a comprehensive evaluation of multiple potential models. Don't just put all your eggs in one basket or rely on the performance metrics of just one model architecture. This ensures a well-informed selection process. It minimizes the risk of choosing an inadequate model by providing a holistic view of performance, suitability, robustness, and resilience across various options before you commit.
Don't just pick the first model that looks okay. Evaluate thoroughly. Good advice. If a financial institution's predictive AI credit approval system testing reveals potentially poisoned training data, what's the most effective control to treat this risk?
Use robust data validation before model training. Catch it early. This is your most effective defense against data poisoning. Robust data validation directly addresses the risk by detecting manipulated labels or corrupted data at the source, preventing these poisoning threats from ever corrupting your model in the first place. You validate before you train.
Validate before you train. Simple but powerful. To sustain AI trustworthiness under dynamic operational conditions, what's the best approach to mitigate emerging risk while maintaining validated assurance levels? How do you keep it trustworthy when things change?
Establish continuous output verification aligned with adaptive risk thresholds. This provides real-time assurance, not just periodic checks. It allows you to capture shifts in risk exposure as they happen in the operational environment and prevent uncontrolled AI behavior or drift. You're constantly checking the output and adjusting based on risk, not just at fixed intervals.
Real-time verification for constant assurance. That sounds advanced. If a hospital's AI solution processes patient data and doctors are suspected of violating privacy regulations using the tool, what's the most appropriate response?
Conduct a root cause analysis followed by an AI risk reassessment. Identifying and truly understanding the root cause of any security-related incident, especially one involving sensitive patient data, is fundamental. You need to know why it happened. This allows you to address the underlying problem systematically. Maybe it's the tool, maybe it's training, maybe it's policy, not just the symptom. Then reassess the risk.
Get to the root cause to fix the underlying issue, not just patch it. What's the most effective practice for maintaining organizational accountability during AI risk management? How do you ensure people take responsibility?
Clearly defining roles and responsibilities for mapping, measuring, and managing AI risk across the board. When everyone knows exactly who is responsible for what aspect of AI risk across the entire life cycle, it ensures effective accountability. It promotes transparency and improves responsiveness to risks as they emerge. Clear roles lead to clear accountability.
Clear roles, clear accountability,
What?
metal, which best ensures that AI systems remain within defined risk tolerance thresholds over time, especially as conditions inevitably change.
Implement continuous monitoring of AI system behavior and performance, coupled with dynamic adjustment of risk treatments. This proactive approach ensures that your systems remain aligned with your organization's risk tolerance despite evolving operational conditions and emerging threats. It allows for proactive adjustments and interventions as needed.
Continuous monitoring and dynamic adjustments for ongoing risk alignment. Which scenario most likely indicates the need to update risk thresholds in an AI risk management system? What's a common trigger?
Regulatory changes that introduce new AI compliance criteria. This is a very common trigger. Regulatory shifts often fundamentally change the risk landscape and what's considered acceptable. This requires a recalibration of your risk thresholds for compliance, ethical use, and impact analysis to stay current with your legal and societal obligations. Your risk boundaries need to move with the law.
Regulatory changes as a crucial trigger for updates. Makes sense. When establishing security metrics for an organization's AI systems, which security metric would best indicate the effectiveness of data protection controls specifically for those systems?
The percentage reduction in unauthorized data access incidents related to those AI systems. This metric directly measures how effective your controls are at preventing unwanted access to the data within your AI systems. It aligns directly with core security objectives around preventing breaches and demonstrates tangible improvement over time.
A direct measure of effectiveness in protecting AI data. Good one. Which activity is best to ensure ongoing oversight of AI system quality and safety?
Human-led validation of data sources and input integrity. While AI processes the data at scale, a human still needs to ensure the quality and integrity of the input data before it's fed into the system, or at least periodically sample and check. This human validation directly influences AI system safety and reliability, preventing flawed or malicious data from corrupting outcomes downstream.
Human oversight for fundamental quality and safety checks.
Mhm.
And finally, for this extensive section on risk, what's the most important consideration regarding the protection of sensitive organizational information when it's being used by third-party AI solutions, especially when developing disaster recovery plans or DRPs?
Ensuring strict data management controls when exposing that sensitive data to third-party AI tools. This is absolutely critical, especially with third parties. Implementing robust data management controls covering access, usage, encryption, retention, disposal is essential for mitigating privacy and security risks, particularly when sensitive organizational data is being shared with external AI solutions, and especially when planning for recovery in a disaster scenario. You need to control how that data is used, stored, and recovered by the third party according to your standards.
Wow, that was a truly comprehensive look at risk assessment and treatment. That was a lot.
Mm.
Now let's shift gears to a topic that I know keeps many security professionals up at night: AI threat and vulnerability management. So if you recently deployed an AI-based web application, what's the best method to uncover any known vulnerabilities within it?
The best method for a deployed web application is generally dynamic application security testing, or DAST. DAST tools analyze applications during runtime from an external black box perspective, essentially mimicking how an attacker would probe it. This makes it ideal for deployed applications where you might not have easy access to the source code. It allows you to find vulnerabilities that only emerge when the application is actually running in its environment.
DAST for those deployed applications. Okay. Next, what best ensures a natural language processing, or NLP, model, say, one used for customer interactions, remains resilient to constantly evolving threats after it's been deployed? How do you keep it safe long term?
You really need a comprehensive, multi-pronged approach here. You should integrate AI-specific threat modeling, adversarial testing, and continuous model behavior monitoring directly into your continuous integration, continuous deployment, or CI/CD pipeline. This embeds proactive threat identification and robust ongoing monitoring for resilience against rapidly evolving threats. It ensures your models stay secure long after it's in production. It's an always-on defense integrated into your processes.
A multi-pronged defense, integrated from development to deployment. Sounds robust. When we're talking about chatbots, what's the most effective architecture control to reduce the risk of unauthorized access to a chatbot's long-term memory storage, where it might keep conversation history?
Implementing strong access control and encryption mechanisms. These are foundational security principles. Access controls, things like role-based access control, RBAC, and robust authentication, along with strong encryption for the data at rest, are absolutely essential for preventing unauthorized access and potential data breaches within those stored AI memory components. Basic hygiene, but critical.
Foundational security controls are always the starting point.
Right.
Which approach best mitigates prompt injection attacks in large language model, or LLM-based chat applications? This seems like a huge issue right now.
Deploying robust input validation and sanitization mechanisms before processing user queries. Definitely. This acts as your crucial first line of defense. It helps to filter out and block those adversarial inputs that are crafted to exploit the LLM's behavior or coerce it into producing unintended or malicious outputs. You're scrubbing the input before the LLM even sees it, hopefully catching the malicious instructions.
Input validation for prompt injection, that's crucial. What's the most effective countermeasure against data poisoning attacks targeting AI models?
You need to actively remove anomalous data that may have been altered by an adversary during the training or retraining process. Data poisoning attacks often work by subtly modifying just a few data points to have a disproportionate impact on the model's learning. Identifying and removing these outliers and anomalous data points, using statistical methods or other techniques, is key to mitigating the effectiveness of data poisoning on your model's performance and integrity.
Remove the poisoned data to preserve integrity. Okay. When establishing effective vulnerability management for AI-based systems, what best ensures that remediation efforts are truly aligned with the organization's actual business risk, not just technical severity?
Building a risk-based AI vulnerability management framework. This framework allows you to prioritize and target vulnerabilities that pose the greatest actual threat to your business operations or objectives. It optimizes your limited resources by ensuring mitigation efforts are proportional to the likelihood and potential impact of a successful exploitation, rather than just chasing every single low-level vulnerability found.
A risk-based approach for smart resource allocation makes sense. What's most effective for addressing security degradation that can happen in fine-tuned large language models, LLMs, after they've been deployed. Fine-tuning can introduce new issues, right?
Yes, it can. You need to validate the model thoroughly post-tuning and then layer on runtime protections. Validating the model after fine-tuning ensures it still behaves as expected and hasn't introduced new security flaws or biases. And then layering on runtime protections like output moderation filters or ongoing input sanitization are critical to preserving security and alignment after those fine-tuned LLMs go live. It's about keeping them secure in the wild post-modification.
Post-deployment validation and runtime protection for fine-tuned LLMs. Got it. What's the first step in creating a threat model, specifically for an AI system? Where do you begin?
The first step is always to identify all the system components, map out the data flows between them, and clearly define the trust boundaries. Where does trust begin and end? This comprehensive initial mapping allows security teams to thoroughly analyze the potential attack surfaces and pinpoint likely vulnerabilities before they even start to define specific threats or mitigation strategies. You can't secure what you don't fully understand structurally.
Mapping out the system and trust boundaries is the essential start. Let's consider a scenario. An AI system suffered a data breach, and the forensic analysis shows suspicious traffic coming from an unfamiliar location consistently over many months. Who is most likely responsible for such persistent, low and slow attack?
An advanced persistent threat, or APT. That pattern fits. APT actors are notoriously known for executing complex, highly organized, and well-funded attacks. They often involve maintaining long-term, stealthy access to a target network, sometimes for months or even years, and systematically exfiltrating data over extended periods without being detected. That pattern of sustained, hidden activity is a real hallmark of an APT group.
Persistent complex attacks the hallmark of an APT. Okay. What's the most significant risk IT professionals must address concerning AI systems that leverage deep learning and neural networks? What's the big worry?
The lack of transparency in the model's decision-making process. It really is. This is what we often refer to as the black box problem, and it's inherent in many complex models. This inherent opaqueness makes it incredibly difficult to detect malicious influence, identify flawed or poisoned training data, or even uncover subtle security breaches hidden within the model's logic. It significantly hinders proper oversight and auditing, making it a deeper and more critical risk than many might realize.
The black box problem, a fundamental challenge for complex AI. Let's imagine another test scenario.
Yeah.
You're testing an AI fraud system, and your IT team finds that an attacker has manipulated input data to mislead the model, causing it to approve a fraudulent transaction without actually modifying the model itself. What scenario best describes this type of attack?
That's a classic evasion attack. Evasion attacks involve adversaries subtly modifying the input data, maybe adding noise, maybe changing a few pixels or words to deceive the AI model. It causes the model to misclassify the input or bypass detection, all without directly altering the model's internal parameters. This technique is commonly used to bypass things like fraud detection systems, malware detectors, or spam filters. They're tricking the model with carefully crafted bad inputs.
Tricking the model through manipulated inputs, evasion. Got it. When developing an AI threat model and trying to identify data poisoning risk early on, what's most effective?
A dual approach often works best. Tracing data provenance rigorously and using statistical anomaly detection. Tracing data provenance helps you track the source and verify the integrity of your training data, ensuring its legitimacy from the start. Simultaneously, statistical anomaly detection techniques can flag any irregular or suspicious patterns in the data distributions, which can indicate potential poisoning attempts early on before they corrupt the model significantly. This combination gives you a strong defensive posture.
Provenance and anomaly detection? A strong combination for data integrity. What is a possible and quite concerning outcome of using a powerful generative AI tool, perhaps one like a fictional past GPT, within an internal system, without proper controls and monitoring?
It could unfortunately lead to access exploits and serious security breaches. Without proper guardrails, strict controls, and oversight, such powerful generative AI tools could potentially be misused internally, maybe accidentally, maybe maliciously to generate or test passwords, simulate credential-based attacks, find vulnerabilities, or even create adversarial inputs that exploit weaknesses in other systems. This significantly increases the likelihood of unauthorized access and security breaches originating from within your own organization.
Gen AI tools need very strong guardrails and usage policies indeed. Let's say an attacker manipulated web-based training data over a period of time. Now, an AI model, which was originally trained on clean data, is inadvertently retrieving and processing these compromised versions during its operational updates or retraining. What scenario best describes this insidious type of attack?
That sounds like a split-view poisoning attack. This occurs when an attacker subtly alters online data sources in the interval between the time the data was originally collected, and perhaps validated, and the time it's actually used for model training or updates. The model thinks it's getting clean, current data, but it's actually retrieving a compromised version that's been manipulated over time. It's a very sneaky way to corrupt a model gradually without directly attacking the training process itself.
A sneaky, timed attack affecting data retrieval. Split view poisoning. Okay. If a cybersecurity team is threat modeling an LLM-powered customer service assistant and discovers that malicious users can manipulate prompts to cause unintended behavior, what's the most effective strategy to mitigate this prompt injection security risk?
Implement prompt filtering and structured input validation robustly. Prompt injection attacks exploit the inherent weaknesses in how LLMs process natural language by injecting malicious instructions or data into user inputs. Robust filtering and validation techniques ensure that user inputs don't bypass security controls or coerce the system into performing unintended, potentially harmful actions. You're essentially cleaning and constraining the instructions before the AI executes them.
Filter and validate those prompts crucial for LLMs. What's the most effective way to structure a threat modeling process for an AI system to ensure comprehensive risk identification and mitigation? How do you make it systematic?
Apply a well-established threat modeling framework. This should include distinct steps like system component identification, thorough attack surface analysis, detailed threat enumeration, like using Stride or MITRE Atlas, and systematic mitigation prioritization based on risk. Threat modeling shouldn't be ad hoc. It requires a structured approach using recognized frameworks to ensure you cover all your bases systematically and effectively manage the identified risks.
Using established frameworks for a structured approach. Good call. What's the primary benefit of integrating a threat intelligence feed with an AI-based threat detection system? Why bother connecting those?
To significantly enhance the detection accuracy of both known and emerging threats. Integrating real-time threat intelligence allows your AI system to stay current with the latest evolving threats, attack vectors, and indicators of compromise. This increases its detection accuracy, helps reduce false positives by providing context, and improves the prioritization of alerts. It's like giving your AI system the latest threat warnings from the global security community.
Better detection with real-time threat intelligence context. What's the most effective strategy to identify vulnerabilities related to model misuse, data leakage, and prompt injection in an LLM-powered customer service chatbot? How do you test for all that?
Effective vulnerability testing must assess the full AI tech stack end-to-end. This means looking beyond just the LLM itself. You have to assess model-level risks, like bias or evasion susceptibility, implementation flaws in your own application code, vulnerabilities in how systems are integrated, and critically, the model's runtime behavior under stress. Comprehensive testing across the entire tech stack is needed to detect deeper, interconnected vulnerabilities that might not be apparent just looking at one piece.
Holistic vulnerability testing, not just testing the model in isolation. Let's look at one more adversarial attack. A company is testing an AI-powered chatbot, and their experiments involve crafting specific text inputs designed to coerce unintended responses from it, maybe revealing private info or generating harmful content. What attack best describes this scenario?
That's another classic example of a prompt injection attack. Prompt injection is an adversarial attack that relies on misleading, carefully crafted inputs to manipulate AI-generated responses. It's often used to induce large language models to perform unintended actions, bypass their safety controls, or even leak sensitive data they shouldn't have access to. You're essentially tricking the AI into doing something outside its intended function by manipulating its instructions.
Prompt injection, again, clearly a very common and critical threat to LLMs. And finally, for this section on threats, which approach would most effectively identify potential adversarial threats in AI systems overall?
Actively testing the robustness of AI models against manipulated inputs. This is broadly known as adversarial testing or red teaming for AI. It's absolutely essential for identifying weaknesses in AI models that sophisticated attackers could potentially exploit using subtle but malicious alterations to input data or prompts. You're proactively trying to break the system in the ways a determined attacker might, to find and fix weaknesses before they do.
All right, that was a truly eye-opening deep dive into AI threat management. So much to consider there. Now, for our final section, let's tackle AI vendor and supply chain management, a really critical area as organizations increasingly rely on third-party AI solutions and components. So if you're integrating a vendor-provided AI system, say for automated recruitment, what's the best course of action to ensure AI security and fairness requirements are met for those candidate assessments?
You really need to establish periodic fairness reviews with multidisciplinary experts. This is key for vendor solutions, especially in sensitive areas like recruitment where bias can have huge impacts. Collaborative evaluations involving maybe legal, HR, data science, and ethics experts ensure that potential biases are detected early and corrected promptly. This promotes continuous fairness in candidate assessments and ensures the vendor solution meets your ethical standards, not just theirs.
Fairness reviews are absolutely key for those vendor solutions, especially in HR. If a financial tech company is deploying a third-party AI-powered fraud detection model, what's the best approach to ensure the integrity of that model? How do you trust a black box from a vendor?
Adversarial testing. You need to rigorously assess how the model responds to manipulated inputs, even if it's a third-party model. This kind of testing allows your security teams to evaluate the model's behavior under various attack scenarios, such as potential data poisoning or evasion attempts. It helps identify potential weaknesses and ensures the model can stand up to real-world threats, providing some assurance, even if it's from a third-party vendor.
Stress testing the model, even when it's from an outside vendor, makes sense. If a company deploys a third-party AI assistant, maybe one that helps summarize emails, and there's a risk of unauthorized access to sensitive email content, what's the best measure to prevent this?
Enforce role-based access control, RBAC, robustly. Ensure employees can only access AI-generated summaries that are relevant to their specific authorization level and need to know. RBAC effectively restricts the AI's responses based on user privilege, preventing employees from retrieving information that is outside their proper access permissions, even if the AI could technically generate it from the underlying data.
Access controls are foundational, no matter where the AI lives or who built it. What's the best way to ensure supply chain integrity for an AI solution that relies heavily on third-party components and datasets? How do you secure that chain?
Auditing those third-party components and datasets thoroughly to verify their security before you integrate them into your system. This proactive verification is critical. It ensures the authenticity and security of all third-party components and datasets, minimizing the risk of introducing vulnerabilities into your systems through your supply chain. You're vetting your suppliers and their inputs meticulously.
Proactive auditing of the supply chain essential diligence. What's most important to prioritize before integrating a cloud-based AI model for patient diagnosis recommendations in a healthcare organization? What comes first?
Securing the patient data using robust encryption methods, both in transit and at rest. In healthcare, patient data is incredibly sensitive and highly regulated. Ensuring its security, particularly through strong encryption, is the absolute top priority for adequate handling of this sensitive information. This is critical for patient privacy, maintaining trust, and meeting stringent healthcare regulations like HIPAA. Data security above all else in this specific context.
Data security above all else in healthcare, for sure. Non-negotiable. Okay, here's a common scenario. A payment service provider uses a third-party AI fraud detection system. The vendor's default is to use customer transaction data for model retraining unless the customer explicitly opts out. What contractual safeguards should the company absolutely include in their agreement?
A strict data usage clause. This clause must explicitly prohibit the vendor's use of customer data for AI model retraining without explicit prior approval or affirmative opt-in from the customer or the provider. This contractual safeguard is vital to prevent potential data privacy violations and ensure compliance with regulatory frameworks like GDPR or CCPA. It puts the control over data usage back where it belongs, not with the vendor's default settings.
Contractual safeguards for data usage, absolutely essential when dealing with vendors. What's the most effective measure to monitor risk across the entire AI supply chain, not just at the initial vetting stage, but ongoing?
Continuously reassess the supplier's security posture during the entire contract lifecycle, not just at procurement time. Effective supply chain risk management is an ongoing process, not a one-time event. It includes regular, proactive reassessments of vendor cybersecurity practices, their compliance, their incident response capabilities, to ensure they maintain their security standards throughout your partnership and adapt to new threats.
Ongoing reassessment for a dynamic threat landscape, even for vendors. What best helps ensure a vendor meets an enterprise's specific security requirements before integration of their AI solution? What's the key pre-integration step?
Conduct a thorough third-party risk assessment, TPRA, or vendor security assessment. This comprehensively evaluates all security-related considerations when integrating vendor solutions. It helps establish clear risk criteria based on your standards and evaluates the vendor's controls against those criteria before you bring their solution into your environment and connect it to your data.
A thorough third-party assessment is non-negotiable before signing or integrating. Now, this is very current. If a marketing company acquired a third-party generative AI service for creating content and then received copyright infringement claims based on the AI's outputs, which contractual measure best mitigates the marketing brand's financial and legal risk?
Vendor-provided intellectual property, or IP, indemnification. This is crucial. This contractual clause ensures that the AI provider assumes liability for any copyright infringement claims arising from both the AI-generated outputs and, potentially, the underlying training data used by the vendor. This is critical for shielding your company from significant legal and financial exposure related to IP issues by transferring that liability directly to the AI provider who created the potentially infringing content.
Indemnification for IP risk vital in the age of generative AI. That's a big one, which best supports embedding, monitoring, and verifying AI security requirements when using vendor AI-enabled solutions throughout their lifecycle.
Using software composition analysis, or SCA tools, and requesting or generating a software bill of materials, or SBBOM, to track all third-party components within the vendor solution. SCA helps identify known vulnerabilities in the external libraries and components the vendor uses. And SBBOM provides critical visibility into those third-party dependencies. Together, they are essential for understanding and managing your supply chain security risks, even within vendor solutions.
SBOM and SCA, proving their worth again, even for vendor solutions you don't build yourself. If an AI chatbot platform allows users to install third-party plugins, which could potentially lead to supply chain attacks, if a plugin is malicious, what's the most effective strategy to reduce this risk?
Restricting the use of plugins to only verified and sandboxed options. Curate the marketplace. This significantly reduces your risk by ensuring that only trusted, security-tested plugins can interact with your AI models and potentially access user data. Sandboxing further isolates these plugins, limiting their permissions and minimizing the potential attack surface from those third-party additions.
Verified and sandboxed, only a smart way to manage plugin risk safely. And finally, what's the most effective approach for AI monitoring when you're relying on vendor-based solutions? What should you be watching?
Your AI monitoring, even for vendor solutions where possible, should include specific metrics tied to model function. Things like tracking output bias drift over time and also tracking anomalies in performance or outputs. These metrics are key for detecting hidden risks that might not be immediately apparent or reported by the vendor. Tracking output bias and anomalies is critical for ensuring ongoing trustworthiness and for early detection of flawed logic or systemic discrimination that might creep into those vendor-provided AI models.
So, what does all this really mean? We've covered a massive amount of ground today, haven't we? Diving deep into the practicalities of governing, securing, and managing AI systems effectively. From navigating complex regulatory compliance, understanding all sorts of bias, to combating sophisticated data poisoning attacks and ensuring responsible vendor relationships, it's abundantly clear that AI requires a meticulous, multifaceted, and frankly, always evolving approach.
Yeah, if we connect this to the bigger picture, it really highlights that successful AI adoption isn't just about technical prowess or building the coolest algorithm anymore. Not at all. It's profoundly about establishing robust governance frameworks, committing to continuous oversight, and applying critical thinking at every single stage of the AI lifecycle. From conception to retirement, it's about proactive risk management, embracing transparency wherever possible, and ultimately building trust in systems that are increasingly shaping our world in profound ways.
Precisely. Well said. And for you, our listener, the takeaway here is that being truly well-informed in the AI landscape means understanding these granular but absolutely critical details. It's not just the hype. This deep dive has hopefully given you a powerful shortcut to that practical knowledge, arming you with insights that go far beyond the headlines and into the real-world practicalities of responsible AI deployment.
And perhaps a final thought to leave you with. As AI continues to evolve at breakneck speed and systems become increasingly autonomous and maybe even inscrutable, how might the very definition of human oversight itself need to adapt? How do we keep pace with these increasingly complex and intelligent machines to ensure they remain aligned with our values?